from rubber manufacturing to precision tire repair and wheel mounting. This technical overview reveals smart methods, safe procedures, and efficient workflows behind automotive service. Natural rubber processing, storage, and selling play a vital role in determining the income of smallholder farmers, who produce nearly 85% of the world's natural rubber. Although rubber supply chains are often long and traditional, farmers can improve their earnings by understanding rubber quality and proper handling practices. After tapping, fresh latex is collected in cups and allowed to coagulate naturally, a process assisted by microorganisms that takes between 8 and 48 hours. The coagulated latex, known as cup lumps, can later be processed into slab lumps, thick slabs, or thin sheets. Thick slabs are formed by mixing latex with coagulants in tubs, while thin sheets are produced by milling slabs through rollers. When dried in a smokehouse, these sheets become smoked rubber sheets. Rubber quality is mainly determined by dry rubber content, thickness, and the level of contaminants. High-quality rubber is thin, clean, and has a high dry rubber content. Organic coagulants such as formic acid are recommended, as harmful chemicals reduce quality and damage the environment. Proper storage is equally important. Rubber should be kept in a dry, shaded place, free from water and contaminants. Finally, farmers calculate the dry rubber content to determine the selling price. By applying good practices from processing to storage, farmers can achieve better quality rubber and higher market prices. The automated rubber tapping robot precisely cuts the rubber tree bark at controlled depth and angle, ensuring consistent latex flow while minimizing damage to the tree. The rubber processing process begins when raw, natural rubber arrives at the factory, usually in the form of latex lumps. The material is unloaded onto a receiving floor where workers carry out an initial inspection. Large foreign objects such as stones, wood, or plastic are removed to protect downstream equipment. After this, the rubber undergoes basic classification using a combination of manual and mechanical methods. Workers break oversized lumps by hand, while conveyors and simple screening devices help separate rubber by size and condition. This early sorting ensures a more uniform and controlled flow of material into the next processing stages. After being shredded into smaller pieces, the rubber enters the washing line, which is a critical stage for improving purity and product quality. The washing system is typically arranged as a long, continuous line consisting of water-filled troughs or large rotating drum washers. These units are designed to thoroughly clean the rubber by combining mechanical agitation with constant water circulation. Inside the rotating drums, the rubber pieces are lifted, dropped, and turned repeatedly by internal paddles or blades. This movement creates friction between the rubber and water, allowing soil, sand, bark, and other embedded impurities to loosen and separate from the rubber surface. As the material progresses along the washing line, fresh water is continuously introduced, while contaminated water is drained away. In more advanced installations, the washing line includes multiple stages arranged in series. Each stage performs a deeper level of cleaning. Cascading tanks allow rubber to move gradually from rough washing to fine washing, ensuring consistent cleanliness. High-pressure water sprays may be installed above conveyors or inside drums to target stubborn contaminants that remain attached to the rubber. To further enhance cleaning efficiency, squeezing rollers or pressing units are integrated into the washing line. These components compress the rubber mass, forcing dirty water out and allowing cleaner water to penetrate more effectively in the next stage. This repeated washing and squeezing cycle significantly reduces impurity levels. Throughout the process, operators monitor water clarity, flow rate, and rubber appearance to ensure quality standards are met. Wastewater is collected, filtered, and either recycled back into the system or treated before disposal. By the end of the washing line, the rubber is clean, uniformly sized, and fully prepared for subsequent operations such as creping, drying, or pressing. After completing the washing line, the cleaned rubber moves forward to the final preparation stages of the factory. At this point, the material has been largely freed from impurities and moisture, making it suitable for further mechanical processing. Depending on production requirements, the rubber may undergo creping to improve texture, followed by controlled drying to reduce moisture content to acceptable levels. In some plants, the rubber is then pressed into compact blocks or sheets for easier handling, storage, and transportation. Quality checks are carried out to ensure consistency in cleanliness, size, and physical properties. This well-controlled sequence of preparation steps ensures that the finished rubber meets industrial standards and can be reliably used in tire manufacturing and other rubber-based products. The rubber production process on the modern SVR10 line starts with the reception of raw coagulated rubber collected from the field. This raw material is unloaded and carefully inspected to remove large visible contaminants before entering the processing line. The rubber is then fed into a heavy-duty shredder, where it is cut into smaller, manageable pieces to ensure consistent downstream processing. After shredding, the rubber passes through a washing system consisting of several water tanks and rotating drums. In this stage, soil, sand, bark, and other impurities are thoroughly removed. The washing water is continuously circulated and filtered to maintain cleaning efficiency. Once washed, the rubber moves through a metal detection unit, which automatically identifies and removes ferrous contaminants to protect machinery and maintain product purity. Next, the cleaned rubber enters a hammermill, where it is further broken down into finer fragments. This step improves material uniformity and prepares the rubber for mechanical forming. The milled rubber is then conveyed to a creping system. Here, a series of rotating rollers repeatedly compress and stretch the rubber, transforming it into thin sheets. This mechanical action improves consistency, removes trapped water, and enhances the physical structure of the material. Following creping, the rubber sheets are transferred to a cutting machine that slices them into small, evenly sized pieces. These rubber crumbs are then conveyed along inspection belts, where operators visually check for remaining impurities and remove any defects manually if necessary. Before leaving the production line, the rubber passes through a final metal detector to ensure it is completely free of metallic contamination. The finished SVR10 rubber material is then collected in bulk containers, ready for storage or further handling according to quality standards. At the Schkopau facility, Styron Deutschland GmbH produces advanced synthetic rubber through closely controlled processes. Latex and polymer materials are engineered into high-performance SSBR for tires, combining wet grip and low rolling resistance, while strict ISO quality control and energy-efficient technologies ensure sustainability and consistent product excellence. Pulse GX50 is a high-performance polycarbonate material developed for the automotive industry. It meets demanding requirements for interior components such as center consoles, blower housings, and instrument panels. The product offers high impact strength, heat distortion resistance, and load density, enabling lighter and more cost-efficient designs. Supported by an experienced international engineering team, Pulse GX50 contributes to innovation, sustainability, and efficient material use in modern automotive applications. The 400-roll rubber calender is an essential machine widely used in the rubber processing industry for both laboratory research and industrial production. Featuring rollers with a working length of 400 millimeters, this calender is designed to deliver uniform thickness and consistent material quality. In laboratory settings, the 2-roll 400 x 150 mm version is commonly used for rubber research and testing, allowing precise preparation of samples in accordance with standards such as ISO 2393. For manufacturing applications, the 4-roll configuration with 400 mm rollers is employed to produce rubber sheets, thin rubber films, or to coat rubber evenly onto fabric substrates. The machine can be configured with different roller diameters depending on the application, ensuring flexibility and accuracy during processing. Thanks to its stable structure and reliable rolling performance, the 400-roll rubber calender plays a crucial role in developing new rubber compounds and producing high-quality rubber products with uniform thickness, smooth surfaces, and dependable mechanical properties. The PE and EVA sheet splitting machine operates with a user-friendly PLC interface and a computer touchscreen, making it easy to control. The operator loads the foam sheet onto the conveyor, and the machine begins the automatic splitting process. The blade position and thickness setting are both controlled and relocated precisely by the PLC system. The sheet is fed through the rotating blade, which slices it into thinner layers, achieving a close tolerance of plus or minus 0.05 millimeters. The machine is capable of splitting sheets as thin as 0.2 millimeters. During operation, the system automatically counts each sliced piece Additionally, a dust collector is attached to the blade sharpener to maintain cleanliness. The touchscreen interface displays real-time operational data, allowing for easy adjustments if needed. After splitting, the processed sheets exit the machine in uniform thickness, ready for further use or packaging. The process is efficient, accurate, and requires minimal manual intervention. Once the conveyor is activated, the material moves forward smoothly toward the working zone. At this stage, the vacuum suction system beneath the conveyor surface is switched on, firmly holding the sheet in place to prevent slipping or lifting during cutting. As the sheet reaches the splitting section, a horizontal blade moves into position. While the vacuum keeps the material stable, the blade penetrates the foam at a preset height and slices through the sheet along its entire length. This operation separates the original thick sheet into two thinner layers with a clean and even surface. After the split is completed, the upper layer is guided forward onto a separate conveyor path, while the lower layer continues on the main conveyor. Next, the machine performs the slitting operation. Multiple vertical rotary blades are arranged across the width of the sheet according to the required strip size. As the material advances, these blades rotate continuously and cut the foam longitudinally, dividing it into several uniform strips in a single pass. Throughout this step, the vacuum system remains active to maintain consistent pressure and cutting accuracy. After slitting, the finished strips are transported to the outfeed section. The pieces are neatly separated and laid out evenly, ready for collection. The HDPE pipe is securely clamped into position. The operator selects the required cutting angle on the control panel, with the machine supporting angles from 0 degrees to 67.5 degrees. The computerized system precisely adjusts the saw blade position. The blade moves smoothly across the pipe surface, ensuring an accurate and clean cut. Throughout the process, the machine monitors blade condition and automatically stops if a break is detected. This ensures safe, efficient operation. After cutting, the finished pipe section is ready for welding into elbows, T's, or crosses. This section provides a detailed introduction to the company's production facility, where high-quality tools and tire-related products are manufactured in Italy. It highlights a modern industrial environment where advanced technology is combined with skilled craftsmanship to provide reliable and durable solutions for the transportation industry. The company focuses on the production and repair of tools, components, and tires, showcasing how raw materials are carefully processed, shaped, and finished to meet stringent safety and performance standards. Each stage of production is closely monitored to ensure consistency, durability, and longevity. Precision machinery and highly trained workers work together to maintain high efficiency while guaranteeing product quality. In addition to tire production, the section also showcases the production of professional automotive repair tools. These tools are designed for workshops and service centers where precision and durability are essential. The production process includes machining, assembly, surface treatment, and final inspection, ensuring that each tool meets stringent standards. Throughout the video, quality control is particularly emphasized. Parts are inspected at multiple stages, and finished products undergo rigorous testing before leaving the production line. This approach ensures that each product complies with international standards and meets customer requirements. It reflects a tradition of engineering excellence, attention to detail, and continuous innovation. By investing in modern equipment, optimizing processes, and employing a skilled workforce, the production department is able to deliver high-performance products while maintaining quality. Overall, it demonstrates how the company's production department has translated expertise, technology, and a commitment to quality into reliable tires and automotive repair tools for the global market. At the wheel load station, bare wheels are placed onto a motor-driven roller with an indexing conveyor that advances each wheel in a controlled sequence. The wheels move through a wheel line vision station, where cameras inspect and identify key reference points. After verification, the wheels enter the wheel soaker station, where lubricant is applied to prepare the rim surface for mounting. In parallel, truck tires in the 19.5-inch to 22.5-inch range are fed into the tire load station. The tire line allows temporary accumulation at an escapement before each tire is singulated at the tire vision station. Here, vision systems authenticate the tire and determine its low point. Once approved, the tire is soaped to reduce friction during assembly. The tire is then rotated precisely to align its low point with the corresponding low point on the wheel. After both components are match-marked, the tire is mounted onto the wheel using the automated mounting system. The completed assembly is transferred directly to the inflator, where the tire is inflated to the specified pressure. Following inflation, assemblies oriented dome up continue forward. While wheels mounted dome down are automatically flipped back over. All assemblies then proceed into the balance system for the next stage of processing. The process begins with a used tire being visually inspected to confirm it is suitable for regrooving. The tire is then positioned securely to prevent movement during cutting. A specialized electric regrooving tool with a heated blade is prepared and adjusted to the required cutting depth. Once heated, the operator guides the blade along the existing tread pattern. As the tool moves forward, it melts and cuts away a controlled layer of rubber, deepening the grooves while preserving the original design. The technician works section by section across the tread surface, maintaining steady pressure and consistent speed to ensure uniform groove depth. Each channel is carefully extended without cutting too deep, avoiding contact with the internal steel belts. Excess rubber is removed smoothly, leaving clean and well-defined tread lines. The operator repeatedly lifts and repositions the tool to follow curved and straight tread sections accurately.
Что?
Throughout the operation, the regrooving depth is carefully controlled to restore traction while maintaining structural integrity. Once all grooves are completed, the tire surface shows deeper channels that improve water evacuation. The process concludes with a final visual check to ensure the tread pattern is evenly restored and safely regrooved. Using the flexible spindle system 386, together with gouge 477, the injured rubber and compromised steel cords are removed in a controlled manner. This operation enlarges the injury slightly but ensures that all unstable material is eliminated, creating a clean and structurally reliable cavity suitable for repair. After gouging, the surrounding inner liner must be prepared to guarantee proper bonding. A buffing wheel 50 by 10 is applied to roughen the rubber evenly around the cavity. This mechanical treatment increases surface area and produces a uniform texture that improves adhesive performance. Once buffing is complete, brush S9035 is used to remove fine rubber dust and loose particles. Thorough cleaning at this stage is essential because contamination can weaken adhesion and reduce repair durability. The cavity is then shaped and refined using powered grinding equipment. Grinder 562, fitted with grinding tool 355, is employed to smooth the transitions between the cavity and the intact inner liner. For more precise cutting, particularly near remaining steel cords, grinder 1007 with carbide cutter 35902 is used. This allows accurate shaping while avoiding unnecessary damage to sound tire structure. Additional grinding tools 359 and 360 are applied to even out the surface and ensure consistent geometry. To further optimize the cavity profile, curved profile wheels are used. The curved profile wheel TCW310 Grit 16 performs coarse shaping, removing irregularities and defining the cavity contours. This is followed by curved profile wheel TCW315 Grit 60, which refines the surface and eliminates deep grinding marks. The result is a smooth, contoured repair area that closely matches the original internal shape of the tire. Brush S9035 is again applied to remove residual dust. Once mechanical preparation is complete, adhesive application begins. Using glue box 697-5, bonding cement is evenly spread over the prepared cavity and surrounding buffed area. The adhesive layer activates the rubber surface and provides the chemical connection required for subsequent materials. Care is taken to achieve uniform coverage without excess buildup, ensuring proper curing and maximum bond strength. The next operation is the application of the cushion gum. Cushion gum is pressed into the cavity to restore lost rubber volume and provide a flexible bonding interface. The material is carefully compacted to eliminate voids and ensure intimate contact with the adhesive-coated surfaces. Proper placement of cushion gum is critical as it helps distribute mechanical stresses and supports the reinforcing textile. Following this step, the application of the metallic textile is carried out. The metallic textile is cut to the appropriate size and positioned precisely over the injury area. It is aligned carefully so that reinforcement fibers cover the damaged zone evenly. Firm pressure is applied to embed the textile into the adhesive and cushion gum layer, ensuring complete contact and removing trapped air. This textile reinforcement restores structural strength where original steel cords were removed. After securing the metallic textile, the reapplication of the cushion gum takes place. An additional layer of cushion gum is applied over the textile to encapsulate it fully. This layer protects the metallic textile from environmental influences and mechanical abrasion while rebuilding a smooth internal surface. The cushion gum is shaped to blend seamlessly with the surrounding liner. The final application of the cushion gum is refined using hand tools. Shears for rubber 491-2 are used to trim excess material and define clean edges. A replaceable pin stitcher 443 is then applied to mechanically stitch the repair layers together. This stitching improves cohesion between materials and reduces the risk of separation during tire operation. To complete sealing of the injury channel, extruder 685 with hole filler strip rubber 600 is used. The extruder injects rubber into remaining voids along the injury path, restoring air tightness and reinforcing the repaired section. The filler rubber is pressed and smoothed to match the internal profile. Through systematic preparation, reinforcement, and sealing, the metallic textile repair restores strength, flexibility, and service reliability comparable to the original tire structure. Throughout the entire procedure, technicians maintain strict control over tool selection, pressure, and working angles to avoid overheating or damaging adjacent rubber. Each stage builds upon the previous one, and visual checks are performed continuously to verify surface quality and alignment. By combining precise mechanical preparation with layered rubber rebuilding and metallic reinforcement, the process ensures that the repaired area can withstand internal pressure, flexing, and thermal loads encountered in service. Before any mechanical work begins, the valve stem is located, and the valve core is removed using a valve core tool to fully deflate the tire. Once the air is released, any wheel weights attached to the rim are removed with wheel weight pliers. This prevents damage to the equipment and ensures proper balance later. The next step is breaking the bead. Using the pneumatically controlled bead breaker pedal, The bead breaker arm is pressed inward against the tire sidewall, separating the tire bead from the rim. This operation is performed on both sides of the tire by rotating the wheel as needed. After the beads are fully broken, the wheel is mounted onto the turntable using inside clamps, which securely grip the inner edge of the steel rim. The mounting head, positioned on a pivoting arm, is then swung into place and locked close to the rim. A pry bar is used to lift the top bead over the mounting head, while the opposite side of the tire is pushed into the drop center of the rim.
So we're going to kind of hook it. And notice how I'm prying right in between these two spots right here. And when I pry, go to the opposite side of the tire and push down.
Activating the rotation pedal allows the tire to be peeled off smoothly. The same technique is repeated to remove the bottom bead, completing the tire removal.
What we got to do to the bottom bead. Pick up the whole tire so you got a nice good gap all the way around. Take the pry tool, again, catch the bottom. So my pry bar is all the way down here now. Pry the bottom bead up and over the lip of the rim, and then rotate the bead off the lip of the rim. Okay. And there you go. So now our tire is removed from our... Make sure that
To install the tire, the bead is lubricated using a dedicated bead lubricant to reduce friction and prevent damage. The tire is positioned correctly on the rim, paying attention to directional markings or DOT information if applicable. The bottom bead is guided over and under the mounting head knuckles, and the turntable rotation pulls the tire onto the rim.
And then under this knuckle right here. So rotate our tire, and then it's tucked under the knuckle on that side. Now all we got to do is just hit the rotation.
The process is repeated for the top bead, with careful hand placement to avoid injury.
Allow that bead to go over the knuckle in the back and under the knuckle in the front. And I'm going to take my hands and I'm going to push down just like this and kind of walk the world's greatest feeling. All right, so we're going to keep rotating it until that bead pops all the way down. Okay, there you go. Next step.
Once mounted, the valve core is temporarily removed to allow rapid airflow for seating the beads. Using the inflation pedal, air is introduced until two distinct pops are heard, indicating the beads are seated. The pressure must not exceed 40 psi during this step.
And then you should hear two sets of pops. You should hear a pop on the bottom and a pop on the top. Now we can go ahead and we can remove this and remove the air hose from the valve.
Finally, the valve core is reinstalled. The tire is inflated to the specified pressure, the valve cap is replaced, and the completed wheel assembly is released from the turntable.
Next thing we're going to do is we're going to go ahead and inflate it up to pressure. Okay. All right, our very last step with this machine is to take the air hose off the valve and then dismount the wheel assembly from the turntable. So over here we're going to slap on the clamps.
The first stage involves loosening the tire bead from the wheel using the bead-breaking shovel and pad. The tire is rolled into position, and the shovel is carefully aligned to break the upper bead just enough to free it without applying excessive force. After flipping the wheel, the same process is repeated on the backside. Once the bead is loosened, the wheel and tire assembly is transferred to the tabletop. The Hunter TCX-575 tabletop is equipped with 4 expandable hooks or clamps that secure the wheel from the inside. Using the foot pedals, the operator controls tower movement, clamp expansion, and table rotation. After centering the wheel, the clamps are expanded to firmly hold it in place, ensuring stability during dismounting. The duck head is then positioned against the wheel using the tower controls. Plastic protectors prevent damage to the rim, and a yellow button allows the duck head to automatically indent into position.
And swing it over in position. If need be, there is a toggle. I can lift it up to clear the wheel and tire assembly. Once it's over in position, it is locked in position. There is no fear of striking the tower, and again, it won't swing out on you because it is locked. I'm going to look for the gap that I made earlier, bring down, and set my disc.
With the machine rotating,
just shy of
the
touching
upper
wheel.
swing arm and leverless hook
Once
are
it's
brought into
set,
place.
I'm going to drop it further.
Lubrication paste is applied to the bead to reduce
Slap
friction
the
and
bead
prevent bead
and
damage
cancel
during
the
removal.
rotation. There's a stopper that will not allow the arm to swing around. It'll stay in this position. I will grab some lube. Once I have the mounting paste, I'll actually apply it to the top bead. This will help dismount the tire off the wheel. Now that that's indenting the yellow tab and sliding the arm out of the way. To clear the wheel and then sliding the arm out of position.
The leverless hook is carefully inserted into the bead at the lowest gap, ensuring it does not interfere with the TPMS sensor. As the table rotates, the hook lifts the bead over the
I
rim.
move my hand to the toggle switch we saw earlier. And at the point that's given, I'm going to insert the hook into the bead. We can see now that the hook is actually set into the bead and has a hold of it. It will not come in contact with your TPMS. There is no fear of striking the TPMS. I can go around continually, again, not harming TPMS. I stop where the
A red spatula is used to maintain separation between the bead and the wheel, allowing the upper bead to be completely removed. The lower bead is then guided into the drop center, hooked, and removed using the same controlled method.
It slides down the barrel I showed you earlier. So again, pull up and in towards you to get it into that drop center. I'm going to take my weight. Up.
After dismounting, the TPMS sensor is inspected and confirmed to be intact.
Slide it toward. Apply
The
base.
mounting process begins with lubricating the tire beads away from the wheel to avoid cosmetic damage.
If you do not apply paste on this part, you can come in risk of tearing the bead of the tire. A torn bead can cause the tire to tower in position.
The tower and duck head are returned to their preset positions, and the lower bead is mounted first, carefully positioning the TPMS out of harm's way. The upper bead is then installed using the swing arm and controlled rotation, allowing the bead to drop naturally into the center as pressure is relieved.
Again, securing it or locking it like so. Now I take and swing the arm around, setting like so. This is in position. I drop it down, actually compressing the sidewall, pushing the bead into the drop center. Now I rotate the table, applying a little bit of pressure here, just enough to keep it in motion. Up more. And now I'm going to swing this arm out so we can see. Pay attention to this piston here. Notice how it drops down. So when this swings from the table turning, it will actually cam up, relieving pressure on the bead, allowing it to drop into the drop center.
Finally, the tower is moved away, the valve stem is accessed, and the tire is inflated, with the valve core removed during initial inflation for efficiency. This method ensures safe, precise, and damage-free tire service using the Hunter TCX-575.